So dear student, now we are going to discuss question number 5.17. Clear? And again, this is a question. From this question we have total number of parts, and each part they are asking to you some questions. Clear? So now we are going to discuss first part number A. So in part number A, question is given to you. Explain qualitatively on the basis of domain picture the irreversibility in the magnetization curve of a ferromagnet. Clear? So irreversibility means what? Irreversibility means first of all, whatever energy that we are supplying, we are not recovering back that much amount of energy. That is known as irreversibility. Clear? But how can we explain here concept of we can say irreversibility in a ferromagnet with the help of a domain picture. So concentrate here. First of all, if I talk about ferromagnet, so in ferromagnet we can say there is some atomic dipoles, and atomic dipoles are arranged in a particular direction in a particular domain. Clear? So if we are not applying any magnetizing field, at that time net magnetic dipole moment that always remains 0. Clear? We can also understand it with the help of this diagram. So yes, so let's suppose I am saying here we have this is a ferromagnetic substance. Clear? And let's suppose actually here we have, let's suppose four, let's suppose like this, I am drawing like this one. Clear? So let's suppose here we have 4 different domains, and each domain atomic dipoles is situated or oriented in a particular direction like this. Clear? So in a particular domain all atomic dipoles are having in a same direction. Now let's suppose here we can see these atomic dipoles are situated like this. So now we can say in each domain we have a large number of atomic dipoles. Clear? And they are actually randomly oriented like this. Clear? So this is a situation that we will find when there is no any magnetizing field. Clear? So at this time we can say we are not applying here magnetizing field, so we can say here net magnetic moment, this value we are getting, that is 0. Clear? 0, I can say this is Joule per Tesla. Clear? But what will happen and why we are getting here irreversibility? So let's suppose if I am applying some magnetizing field on this, we can say if I am applying here magnetizing field on this ferromagnetic substance, what will happen? Listen carefully. Now as we are applying here magnetizing field, at the time atomic dipoles, that is always try to gain their orientation according to this magnetizing field. Clear? So we can see here slowly these domains are actually increasing like this. Clear? We can say in this direction we are getting maximum number of atomic dipoles. Clear? And like this. Clear? So like this. So we can say as we are applying this magnetizing field, this domain is actually try to align themselves in a particular direction, and we can see after that this ferromagnet is magnetized. Clear to you? So it means if we are providing here some external magnetizing field, actually we are utilizing some of its energy in to align these dipoles in a particular direction. Yes or no? But let's suppose if I say to you, let's suppose they remove this magnetizing field, then what will happen? So as this magnetizing field is removed, at that time some of atomic dipoles again gain their original domain orientation, but this is not possible that all the atomic dipoles will not recover their original orientation. Clear? It means whatever total energy first that is utilized to align them in a particular direction, that is not recovered back. Clear to you? It means we can say total energy, actually we are getting some gap in an energy or some difference in an energy, so that actually difference of energy is dissipated in a form of heat. Clear? So we can say this is a concept of irreversibility, and this is qualitative explanation and basis on domain theory. Clear? So this is all about part number A. Clear to everyone? Yes. Now I am going to discuss part number B. In part number B, it is given the hysteresis loop of a soft iron piece has a much smaller area than of a carbon steel piece. Clear? So I think you know hysteresis loop. We can say, let's suppose if you draw here a graph between B and H. Clear? And we can see the curve we are drawing like this one. Clear? So actually if we draw this BH curve for two different two different magnetic materials, first I am drawing here, this is for the soft iron piece, and second one that I am drawing for the carbon steel. So let's suppose this is a diagram for carbon steel. Clear? And if you draw here for I can say a soft iron piece, how can we draw? For soft iron piece, I can draw it like this, this one and this one. Clear to you? So now from here you can see, if we talk about total area of BH curve, what I am saying to you, if I am talking about total area of BH curve. Clear? So if I am saying this total area of BH curve, you can see that BH curve area is more for carbon steel. Clear? So I can say BH curve area, or we can say BH curve area, or we can say the area of this hysteresis loop. We can say this is area of hysteresis loop. Actually it provides here total amount of energy that is dissipated in the form of loss. Clear? So we can say definitely we can say hysteresis loop, we can say definitely the heat energy that is dissipated in a carbon steel is more compared to soft steel. Clear? This is a diagram for soft steel. Clear? So directly you should keep in your mind only there is a one concept, area of this BH curve, that provides you the energy, total heat lost, or the heat lost in the form of we can say energy lost in the form of heat. Clear? So this is all about part number B. Clear to everyone? Now we are going to discuss here part number C, and in part number C it is given to you a system displaying a hysteresis loop such as a ferromagnet is a device for storing memory. Clear? So explain the meaning of this statement. Now listen carefully. Generally we see, if we talk about BH curve, so we can understand this BH curve by applying some magnetizing field to ferromagnetic substance. Clear? But this ferromagnetic substance or its magnetic field, or we can say its magnetic field, it depends only on one factor? No. Actually it also depends the number of times this cycle is repeated. Clear? So we can say more the number of times this cycle is repeated, we can say we will find the less value of magnetic field and corresponding to that magnetizing field. Clear? So it means we can say here, we can say this system of hysteresis loop, we can utilize it as a storing memory, and it can represent the number of times this magnetic cycle is completed. Clear? So this is the meaning of this statement. Now we are going to discuss part number D. What kind of ferromagnetic material is used for coating magnetic tape in a cassette player? Clear? So for the coating of cassette that we utilize in a for the coating of magnetic tape that is utilized in a cassette, we utilize here a particular material that is known as ceramic. Clear? So we utilize here a particular substance that is ceramic. Clear to everyone? Yes. Now if I am talking about part number E, so in part number E it is given to you a certain region of space is to be shielded from magnetic field. Suggest a method. Clear? So let's suppose here I am taking here, this is soft iron ring. This is what I am saying, this is soft iron ring. Clear? Let's suppose this is soft iron ring. Clear? And let's suppose we place any particular we can say measuring instrument in the space between these soft rings. Clear? So we can see a certain region of space that is to be shielded from magnetic field. So this is a one method. Let's suppose if we place soft iron ring, soft iron ring that is occupy or surrounding at a particular place that we want to protect from magnetic field lines. Now you can say, sir, what will happen? So actually we can say, let's suppose from this direction magnetic field lines is coming like this, clear? So magnetic field lines, when it will when it is going through this iron ring, actually it will passes through iron ring and it will goes like this, clear? So from here we can see that magnetic field lines, this is passes through this iron ring instead of it is going through the space between this iron ring, clear? So we can say like this, we can protect any measuring instrument from magnetic field from the magnetic field, clear? So this is one of the method that you can utilize, clear? So this is all about this question.